I'm going to introduce a very different solution for state management using MobX and how it can connect to Angular, both Angular 2 and Angular 1. My name is Adam Klein. I work at 500 Tech. I'm the CDO. We do development, consulting, and we teach courses in React and Angular 2, and also Node.js. And we also co-organized this conference. Myself, I'm a front-end developer and consultant, and I recently started writing open source libraries for Angular 2. So I have ng2.3 and ng2 MobX, which I'm going to display in this presentation. And I'm the co-organizer of this conference. And a fun fact about me, I used to have a Jufro. I know it's hard to believe, but trust me. So this talk is going to revolve around this example. So I want to explore it a bit with you so you understand what I'm talking about. So we have an application with a list of frameworks. We can select them using checkboxes, and you can see a list of selected items at the top. And we also have a master checkbox. We can check it or uncheck it, and all of the children will get affected, and also the list of selected items. Also, when we check one of the children, the master checkbox value is automatically updated and recalculated. We can also add new items to the list. In this case, we add jQuery, and you can see that also the master checkbox is now automatically unchecked because we added a new item. And if we filter the list, then the master checkbox will reflect and affect only the list of the current filtered items. Last but not least, we can also remove items from the selected list using the X button. So it looks simple, but it's a bit complex, a lot of relations. And I want you to take a second to think how you would solve it using the tools that you currently know. And this is how most of you look right now. Okay, so the first approach, which is a straightforward approach, is the imperative way. Imperative means everything that happens, we write code that makes sure everything else gets updated. So if the user checks, for example, a regular checkbox, then we need to write code that updates the list of selected items and that recalculates the value of the master checkbox to reflect the new state. And again, if the user clicks master checkbox, we need to update the list of selected items and also update the Boolean value inside all of the current filtered items. If the user adds a new framework to the list, then we have, again, to recalculate the list of filtered items because maybe he added jQuery, but we currently have a filter that jQuery doesn't match, so we have to recalculate it, and the value of the master checkbox. And as you can see, everything depends on each other. And it's important to know there's also a matter of order. So we have to first calculate the list of filtered items, and only then we can calculate the value of master checkbox. So this is a really good demonstration of what we call spaghetti code, which means that everything in our application knows about everything that needs to happen in our application. So we basically have no separation of concerns, which means that every new feature that we add to our application will require more and more effort from us to introduce. So our productivity decreases over time, which is bad. But again, you see this type of code anywhere. I also write this type of code because we don't really have the tools to avoid it. So the other approach, instead of being imperative, is being declarative. It looks promising. So declarative means, let's say we take the list of filtered items. We have a function that just recalculates the current list of filtered items. It takes the filter and the list of items and see which one matches the filter. And then if we're using Angular, either 1 or 2, we just bind in our template directly to the value, to the return value of the function. Which means that the only place that knows about how to calculate the filtered items is the function that I showed, and we can rest assured that it will always reflect the current state. What is the problem with this? Anybody knows? Performance, performance, performance. Thank you. So how many times will the filtered item list get recalculated? How many? 20? No. The answer is obviously too much. So I'm demonstrating, again, getting the list of filtered items. So I'm demonstrating here, I'm console logging every time. It would be funny if I look back and there's no presentation. Like, oh, okay. So I'm console logging every time something gets recalculated, and as you can see, just the application loaded, and we get a ton of recalculation. And because we're using Angular, everything that happens on the screen, whether it's the digest cycle or Angular 2 change detection, every component gets re-rendered, and they ask again for the list of filtered items or whatever. So everything we do on the screen, even if we just type in random inputs that don't change anything, every letter that every keystroke will cause everything to recalculate. Which, in this example, you can't really see the performance issues, but trust me, it just gets unusable after a very short time. So can we be declarative, but still stay performant? And the answer is yes, we can, using the magician called MobX. And he's a smart magician, not like Angular 1 digest cycle magician. So MobX is a library written by Michel Veststrate, that's how you pronounce his name, from Mendix. He was actually here in September. It was originally written for React, and it's very popular for React and gaining popularity. But it's completely framework agnostic, which means it can be used with any framework. And it automatically recalculates whatever we need when we need it to be recalculated. And the good thing about it is, as opposed to other state management solutions, it works with plain objects, which means we don't need to relearn how we write code to use it. We can write code the same way we know, and it just decorates our regular classes, and I'll show it later. And as I said, it's very popular and gaining more and more popularity. So first thing that we should do, and this is regardless whether we use MobX or not, MobX is just one solution to do this, is to take the state out of the components. So in our case, we can break down our application to small, single-purpose components, and each one of the components is completely unaware of the other components on the screen. That's why it's single-purpose and it's encapsulated. There's no events being sent between the components. So we can have the same application. Let's say we remove the list of selected items from the page. Everything will just work the same. And then we have the state. So the components themselves don't hold the state. They use some kind of globally available object. In Angular, it's an injectable called the state, and they can change the state or subscribe to changes from the state directly. So they don't need to know about other components. If you still don't understand this concept, I recommend reading about it. If you read about Flux architecture, it describes it really well. So this is not something that was invented by MobX. MobX is just one of the things that help us build our application in a sane way. So when we think about state in MobX, we need to think about first our minimal state. In our case of this application, it's the current filter, whatever the user typed, it's a string value, and the list of frameworks and their current Boolean value, whether they're checked or not. We don't need to keep on the state, for example, the list of filtered items, because we can always derive it from our minimal state. So on our derived state, we have the list of filtered items, the list of selected items, and the value of the master checkbox. At any given moment, we can calculate these from the minimal state. We don't need, if we save them on the state, we will have duplication and we can go out of sync. So let's see how we do it with MobX. So first of all, as I said, MobX works on plain objects. So we take the state out of the component. This is just a class. And because we're using Angular, we make it injectable, so we can use it in our components. And then we define the minimal state. So who knows this syntax of defining class properties? So if you're using TypeScript, it's built into TypeScript. It just means that every object of type state will have, for example, filter property on it with this initial value. It's the same as writing this dot filter equals empty string in the constructor. And if you're using ES6, you can also use this class property. You just need to set bubble stage to 0. And it also knows about this syntax. And if you're using ES5, get out of here. Okay, start using ES6 right away so you can use all the cool features that it has. Now to make it observable, so far there's nothing MobX about it. To make it observable, we import observable from MobX, and I just want to note this has nothing to do with RX observable. It's just the same name. And we decorate our class properties with the observable decorator, and that's it. So this is our minimal state. Our computed values are the same declarative functions that we saw earlier, but we add the computed decorator, and we make them a getter function. Getter function is also part of ES6 and TypeScript, and it means that we don't call dot filtered items with parentheses, we just call dot filtered items, and the getter function is invoked. So far we good? Cool. Now, I will describe a little how MobX works. The first time you call filtered items, MobX calls this function and gets the filtered items. But it also notices all the observables and computed values that you used inside. So for example, this function is using the filter observable, the items observable, and the item name property on each item, which is also an observable. And then it builds the dependency tree that we saw earlier. So now MobX knows that every time the filter is changed, it needs to recalculate the filtered items. Changing the state, because we're using plain objects, is just a matter of setting a property, and that's it. Now, I showed you the observable decorator, and what it does is override the getter and setter functions of that property. This is why when we set a value on the filter, MobX knows about it, and because it has a dependency tree, it can automatically recalculate everything that's dependent. So if we set the value of the filter normally, we don't need to do anything else, MobX will recalculate the filtered items. There's one small thing. Use the action decorator. It's for anything that changes the state. It's not mandatory, but it's best practice, and I won't go into details because I don't have enough time. Now, MobX is lazy. If we don't tell it, listen, we want to observe these values from the state, then it will not do any recalculations. Which is good for us because we're going to use it in our UI components. And for example, if a certain component is not on the page at the moment, there's no need to recalculate the things that it uses. So there is one missing part that I still didn't show of MobX, which is how we observe values. So what we're currently missing, if you already understood what MobX is, and I hope you kind of starting to understand, we're missing this part of connecting to Angular 2 and saying, okay, I want to observe the values from my components, and re-render them every time there's a change. So basically what we want is to connect ng2 with MobX. Now, I don't know how tired you are, but I really want you to sing with me this song. And we will start with MobX. Are you up for it? You want to? No, there's video. So, I have MobX. No, you have to sing with me. And I have MobX. I have ng2. ng2 MobX. I think you can get a round of applause for that. Actually, I expected a bit more cooperation with the singing. I hope that you will overshadow my voice, but it didn't happen. So a month ago, I wanted to integrate MobX into my Angular applications, and I Googled ng2 MobX to find a connector, and I have bad news. I didn't find any connector to Angular 2. This talk is over. Thank you. But the good news is, I wrote one. So now you can find it under our GitHub account of 500tech, ng2 MobX. Yeah, you can clap if you want. I don't mind. Now, one word about open source. I always try not to contaminate the jungle of open source. So I actually emailed Michel, who wrote MobX, and I asked him if somebody is already writing it. And he told me that nobody's writing, so I knew I'm not creating any duplicate open source libraries. So the library is just 64 lines of code. It's very simple. And it automatically observes whatever we need from the state in our components, from our components. And of course, whenever a component is destroyed, it will deregister the observers. So before showing you how you use it, I'll show you the end result of after you're using it. And basically you can see, remember the demo from before? Now you can see that only what needs to be recalculated is recalculated, and only once. So for example, if I just type inside a random input, nothing gets recalculated, only when I hit enter, and then there's another framework in the list, and it needs to do the recalculations. So the way to use it is, first of all, we have our state that we created before, and we injected into our component. By the way, you can also just import it if you don't want to use dependency injection. But if you're using Angular, maybe your class is using other dependencies. So this is probably the common way to do it. And then we can just use the object in our template the normal way. We don't need any filters or anything. We just use the property as it is. And now, the magic. This is what you need to use MobX with Angular 2. So basically, you just add the MobX autorun directive. And if you don't know the asterisk notation, it's structural directives in Angular 2. It's like ngIf or ngFor. And the directive will automatically see what you're using inside a template. So everything inside the template, now it's just filtered items, but you can have other stuff. And it will add that to the dependency tree. I mean, MobX will add to the dependency tree. And whenever something changes, it will run change detection on the component, which means it will re-render it. So for example, here, if we change the filter, MobX knows, let's do it here. If we change the filter, MobX knows that it needs to recalculate the filtered items, and then it says, oh, I also need to re-render the framework's filter component. But it will not re-render all the other page components on the page. For example, selected frameworks component will not be re-rendered. And you can imagine a page with 500 components, and only like 2 will be re-rendered, as opposed to everything. So now you would expect the red counter is the counter of how many times change detection runs on a specific component. And now you would expect it to rerun only whenever it needs to, right? Like if we change the filter, it will just run once. And as you can see, huh? Why is it happening? Oh my God. Everything we do, everything gets change detected all over again. That's weird. So yeah, I'm also surprised. I thought it would work. So anybody knows why is this happening? No, just have the right observers that we need. Like if I just type in the new framework field, there's nothing attached to it, so why is it running change detection? Anybody knows? Zone, exactly. So Angular is an amazing framework. It knows everything that we do, and it reruns change detection on all of our componentry using something called zone. We don't have a talk about zones in this conference, but Google it. That's basically what it does. Everything like timeout, clicks, keystrokes, Ajax calls, it will rerun change detection on all of our components, unless we tell it not to. So Angular is considerate. We have a change detection strategy, and well, actually there are only two possibilities for the change detection strategy, which is the default, which is just said, or on push. On push means if you rerun change detection on a component, this is on a component level basis, not the entire app. Only if one of the inputs of the component changed, or if we manually rerun change detection. And I'm reminding you, the MobX auto-run directive reruns change detection manually. So basically, if our component only relies on the input it gets and the state, the MobX state that we have in our application, then we can use onPush, and we don't need to re-render rerun change detection every time something happens in our application. It's the same approach like Redux or Rx to make our components decoupled and pure, but it's just in a different way. So this is the demo. This is the real demo when using onPush strategy. And as you can see, I'm typing, nothing happens. Only when I change the state, then the components that are dependent on this state change. And the cool thing about it is that MobX, I said it's a smart magician because I don't need to tell it, listen, in this component, I'm going to use this and this and this observables and this computed values. Just from running the template the first time, running change detection the first time, MobX builds the dependency tree, and then it knows to rerun it the next time. I have a final demo, which I think is the coolest one. Actually, Boris told me to put it in the slides, so thank you, Boris. I hope it works. Well, it's a video, it will work. From here, I'm just showing that I'm setting the current filter from the console. So I put the state object on the window so I can use it from the console. And I'm just going to set a value of the filter. And you will see that the UI, hopefully, let's cross our fingers, the UI will get updated and change detection will run only once. Are you ready? No. Are you ready? Oh, I'm sorry, I'm out of time. Let's see it. So just setting a variable, and boom. So I'm really excited about this, and I see that you're also excited. The applause is actually not for me, it's for Michelle, who wrote MobX. As I showed you, my library is just connecting it to Angular in a very sophisticated way. But the whole idea behind MobX was created by Michel, and I really like it. Specifically because we can use just plain objects. So a small comparison with Redux. So as I said, we're using plain objects. If you use Redux, you know that handling immutable data is a pain in the ass, and you also have this whole cycle of actions, reducers, middlewares, etc. It's automatic, as I said, it automatically builds the dependency tree, and it has the built-in computed values, which, for example, if you're using Redux, you have to use reselect, and it's a bit more tedious. Now, again, Redux has a lot of advantages. I really love it, and it's suitable for a lot of projects. I just think it's really good to know this tool as well, and if you know both of them very well, you can even combine them. So the next thing I want to do, and I already started, is writing the MobX connector for Angular 1. We're actually already using MobX in some of our Angular 1 applications, and it works great. Think about, in Angular 1, you used to take out your state to a service, which is just a class. So simply by adding MobX decorators, you get a reactive state instead of just a static state, and you can have computed values. So I was Adam Klein, I'm still Adam Klein. Wait. This is my email, and this is my Twitter, although I'm new in Twitter, so it's not so exciting. I still didn't upload, but it will be uploaded to our SlideShare at slideshare.net/500tech. And the repositories with the code for using MobX also will be uploaded to these repositories. Now, thank you.